So question number 8, the figure below shows the behaviors of emissions by a radioactive isotope X. Use it to answer the question follows. So as you can see, the magnetic field where some of the radiations have been emitted, and I look at this magnetic field, we have the top part of this magnetic field which is positively charged and the lower part is negatively charged. Since we have some of the radiations which are negatively charged, according to the laws of magnetism, it says unlike poles attract and like poles repel. Beta particles are negatively charged, so they will move upper side of this magnetic field which is positively charged. We have gamma rays. Gamma rays has no charge, so it will not be affected. So it will pass through the center of the magnetic field. We have alpha particle which is positively charged, and when you look at the lower part of the magnetic field, it is negatively charged, so it will be attracted at the lower part of this magnetic field. Why does the isotope X emit radiations? Isotope emits radiation because of stability. When the nucleus is not stable enough, some of these particles will be released in order to attain the stable configuration. How does it determine the stability of a nucleus? The stability of a nucleus is being determined by two factors. First one is the binding energy that is within the nucleus, and the second one is the ratio between the protons and the neutrons. When the ratio is 1:1, that is where the nucleus is said to be stable. B, name the radiation label T. The radiation label T, it is alpha particle. Why? Alpha particle is positively charged, and when you look at that particular part of the magnetic field, it is negatively charged. So the particle that will move at the lower part of this magnetic field, it is alpha particle. See, what is half-life? This is the time taken for the radioactivity of a specified isotope to fall to a half its original value. So when you're given a mass of an isotope, it will decay to a half of its original mass. We take an example of an isotope which is having a mass of 40 grams, so it will decay to 20 grams of it. Maybe it can take like 1 hour, it can take like 20 seconds to decay. So when it takes 20 seconds to decay to 20 grams from 40 grams, we say that is a half-life.